Hello everyone. In this video, I will teach you how to convert or transform the standard form of quadratic function to the vertex form using the vertex formula. Now I understand there's another way of doing that, and that is by means of completing the square. I also have a video about that. Okay. So we have here a standard form y equals ax squared plus bx plus c, and the objective is to convert that to the vertex form. And the reason why it's called the vertex form is we can see the vertex, it's h and k of the parabola of the quadratic function. So use the vertex formula. So when working with the vertex form of quadratic function, we can use this one as our h, that's negative b over 2a, and then after that we just need to solve for k, which is we will be using function notation. So whatever the value of h, we will replace all the x's by that h, and then we can solve for k. So I have here 4 examples, so please bear with me. Here, the first thing we need to do is identify a and b. Okay. Again, just a reminder, the objective is to convert that into this form. Okay, so clearly we can have we already have the a, which is 1. We just need to solve for h and k. So for the h, the formula of that is negative b over 2a, right? Our b is negative 2. Wait, there, negative 2. So it's negative 2 over 2 times 1. So that's 2 over 2, which is equal to 1, right? So now we have the h, which is 1. The next thing we need to solve is the k. So k, if you remember, the formula is f of h, right? So meaning I will copy the given here. We will replace the 2 x's by 1. So 1 squared minus 2 times 1 plus 4. This is 1 minus 2 plus 4. 1 plus 4 is equal to 5, right? And then minus 2, and that is equal to 3. This is our k. So once we have all those, variables that we need, we just need to plug them in the formula. So 1 x. So for h, you need to change its sign. It's positive 1, so here you're going to make it minus 1. Okay. Square plus 3. So for the k, you just need to keep that. Now, there's no need for us to write the 1, so that means we can just write the quadrat or the vertex form as this. Okay. Okay, let me give you another example. I have 3 more examples here. You just want to make sure you understand the procedure, but once you understand this one, you're good to go. Okay, so let's go to the second one. Again, the objective is to convert that into y equals a times x minus h squared plus k. Okay. We need to find a and b. A is the numerical coefficient of x squared, so here it's negative 1. B is the numerical coefficient of the x term. So x squared term is basically the leading term. And here we have negative 6, which is b. Let's find h first using the formula. So here we already have the a, which is negative 1. Negative 6 over 2 times negative 1. This is 6 over negative 2, right? Which is equal to negative 3. This is our h. Okay. Now for k, that's f of h, meaning we will replace all the excess in the given by the value of our h. Here it's negative 3, so we put negative 3 squared minus 6 times negative 3 minus 8. So I will write the negative sign here. Negative 3 squared is equal to negative 3 times negative 3, which is 9. Negative 6 times negative 3. We will consider that minus 6 as negative, so when we solve that 2, it's going to be negative 6 times negative 3, which is plus 18 minus 8, right? That's 9 minus 8, which is equal to 1. That's our k. So now we have the a, the h, and the k. We just need to plug them in the formula. We have negative 1, x negative negative 3, so that would be plus 3. That means you just need to, switch the sign of that. When you put it in the formula for the k, you keep the sign of that. Okay. So there's no need for us to write negative 1. We can just write negative here, plus 3 squared plus 1. There you go. That's the vertex form of the given. Okay. Okay, last two examples. Here, again, the objective is to convert that into this. We need to find a and b. A is the numerical coefficient of the leading term. B is the numerical coefficient of the x term. So for h, that's negative b, which means negative negative 16 over 2 times 2, right? So negative negative 16, that's 16 over 4, which is equal to 4. That's our h. So we already have the h and our a. We just need to find k. So k is equal to f of h, which means we will replace all the x's here by h. So this is 2 times 4 squared minus 16 times 4 plus 35. So I'll write 2 here first, and then 4 squared, multiply that. That would be 16. Now the usual problem here with the students is they multiply 2 and 4 and then they square it. No, you're not going to do that. You got to keep the numerical coefficient of that x squared, which is 2 there, and then solve for 4 squared first. So this is minus 64 plus 35. This is 32 minus 64 plus 35. I think it's better if we add first 32 and 35, and that will give us 67 minus 64, which is equal to 3. This is our k. So you have the a, we have the h, and we have the k. Just plug them in the formula. Oh, sorry. So we have 2 times x minus 4 square. Again, it's positive 4, so here you will see minus 4. You switch the sign of that, plus 3, and that's it. There. That's the vertex form of this standard form of quadratic function. Let's go to the last one. Again, the objective is to convert that into this using the vertex formula. Okay. So in the vertex formula, we just need to find a and b first. Our a here is negative 3. Our b is 6. So for h, the formula of that is negative b over 2a, right? So negative 6 over 2 times negative 3. Okay. This is equal to negative 6 over negative 6, which is equal to 1. That's our h. Okay. So we have the a, the h, and then the k. So k is equal to f of h, meaning we will replace all the x's here by 1. There. So negative 3, 1 square is 1, plus 6 minus 1 is negative 3, plus 6 minus 1, that's 3 minus 1, and that is equal to positive 2, which is our k. So now we have the a, h, and the k. We just need to, plug them in the formula. Negative 3 in the form. Negative 3 times x minus 1 square. So that's plus 1, right? That's positive 1. So here you're going to change the sign. For k, you keep the sign. Okay. So there you go. That's how you convert the standard form of quadratic function into the vertex form using the vertex formula. So if you want to watch the other video, it's still the same objective, converting the standard form to the vertex form, but the procedure here, there is different. It's going to be completing the square. So please watch that video also so you can compare which one works for you better. Okay, say that's it. Thank you and bye.